There's a specific kind of muscle memory we've all developed.
Oh, yeah.
You wake up, you grab your phone, you open an app, Facebook, Instagram, whatever, and you just scroll.
Mm-hmm. Thumb scroll.
It's hypnotic.
Yeah.
And it feels like the simplest thing in the world. It's just a list,
Right?
Status updates, brunch photos, cat videos.
Right.
But I was looking through this stack of research for today, really trying to get my head around the system design specs. And honestly, under the hood,
Yeah.
that simple list is a monster.
It is. It's an absolute beast of engineering.
It is.
It's one of those things where the user interface, that, clean vertical stream of content,
Yeah.
it completely betrays the chaotic complexity required to make it work.
Right.
We aren't just talking about displaying a list from a database. If you tried to build this the way you build a basic blog, the whole thing would just catch fire.
Well, that's the thing. We aren't building this for 100 people. The scope we're looking at today, based on the specs we have, is massive.
How massive are we talking?
10 million. We are designing a feed for 10 million daily active users.
10 million.
Okay. And it has to support media, images, videos, all of it.
And that scale, that number, it changes the physics of the software. For a college campus, sure, you could code a newsfeed in an afternoon, but 10 million users. You hit what engineers call the scalability wall.
The scalability wall.
You have to deal with latency, data consistency, and the terrifying possibility that a single popular post could literally melt your servers.
And that's our mission for this deep dive. We're going to architect the infinite scroll. We've got the blueprints, the API docs. We're going to figure out how to serve this content without everything crashing down.
Let's do it.
But let's start with the naive approach, just so I can understand why it fails. My brain just thinks, okay, I follow people, they post, the app just asks the database, give me everything my friends posted, sorts it by date, and shows me. Why isn't it that simple?
Because of the math.
The math.
Think about the query you just described. Select all posts from everyone I follow. Imagine you follow, say, 500 people, and 10 million other people also follow 500 people. If everyone opens their phone at roughly the same time, say 8 a.m., the database has to hunt down millions of posts scattered all over the disk, filter them, sort them.
And it has to do that for every single person simultaneously.
Precisely. A standard database query just chokes on that. It's too much processing per user. You'd be staring at a spinning wheel for 10, maybe 20 seconds.
Which is the death of any social app. If I have to wait that long, I'm gone. I'm checking my email.
That's the core tension. The read has to feel instant. So to solve this, we have to split the entire system into two completely different worlds.
Two worlds.
The blueprint creates two flows, the feed publishing flow and the newsfeed building flow. Or, in engineering terms, the write path and the read path.
Okay, separate paths. But let's start with the right path. So this is what happens when I hit post.
Let's look at the API layer. According to the documentation, when you post an update, your app sends an HTTP PRC request to the server.
To a specific endpoint, I assume.
Yep. Specifically V1 ProFeed, and you're sending the content, text, image links, and an auth token to prove you are who you say you are.
Simple enough.
Yeah.
But once that hits the server, it's not just stored somewhere.
No, it starts a journey. It goes from your phone through DNS, hits a load balancer, which spreads the traffic out, and lands on a web server.
Okay.
Now, here's where it gets interesting. The web server persists the post to the database, sure, but then it triggers something called a fan-out service.
Fan out. That sounds mechanical. What's fanning out?
Think of it as the distribution engine. Its only job is to deliver your post to all your friends.
Okay.
If you have 5 friends, that's easy. But if you have 5,000, it's a job. And this is where we run into the great debate of newsfeed design. Push versus pull.
Push versus pull. I feel like this is a huge architectural decision. Break that down for us.
Okay. Option A, fan out on write. This is also called the push model.
Push.
In this scenario, when you write a post, the system immediately calculates who needs to see it. It goes to all your friends' pre-computed newsfeed caches and pushes your new post ID right onto the top of their list.
Wait, so it's proactive. It does the work before my friends even open the app.
Yes. The heavy lifting happens when you write. The huge pro here is that when your friend opens the app, their feed is already built. It's just sitting there in memory.
So it's instant.
It's instant. No calculation needed. They just read the list.
That sounds perfect. Why wouldn't we just do that for everything?
Well, think about the cost. What about your friend who hasn't logged in for 3 years? In a push model, the system is still dutifully updating their feed every time you post. You're wasting compute cycles on a ghost town.
That seems inefficient, but maybe manageable.
It is, but there's a much bigger issue. the hotkey
I've got
problem,
a key problem.
or what I like to call the Justin Bieber problem.
Okay, I think I see where this is going. I have maybe a few hundred friends. Pushing my post to 300 lists is nothing.
A millisecond.
But Justin Bieber or Taylor Swift, they have millions of followers.
Maybe 100 million.
So if we use the push model, the moment Taylor hits post, the fan-out service has to find 100 million follower caches and update them all simultaneously.
Instantly. And that creates a massive, massive spike in traffic. It's a hotkey issue. It locks up the database. It floods the cache servers. The whole system just lags.
It's basically a self-inflicted denial of service attack.
Exactly. So for celebrities, the push model is a disaster.
Okay, so that perfect model falls apart at scale. So you have to go to option B, the pull model.
Right. Fan out on read. In this model, the system does almost nothing when the celebrity posts. It just saves the post in the database.
The lazy approach. I like it.
But when a follower opens their app, that's the read moment, the system says, oh, you're here. Let me go fetch all the recent posts from everyone you follow and build your feed for you right now.
Oh, so it pulls the data on demand.
Yep. The pro is we don't waste time on inactive users, and there's no hotkey problem. The work is spread out.
But we're back to my original problem, aren't we? If I follow 500 people, compiling that on the fly is slow.
It is.
I'm staring at the spinning wheel of death again.
You've identified the trap. Push is too heavy for celebrities. Pull is too slow for normal users.
So is there a middle ground?
The secret sauce is a hybrid approach, and this is really brilliant.
A mix of both.
Exactly. The architecture uses both, based on the user. For the vast majority of us with normal follower counts, the system uses the push model. We get those fast pre-computed feeds.
Okay.
But for celebrities, anyone with followers over a certain threshold, the system switches to pull.
That is incredibly smart. So if my friend posts, it gets pushed to my feed cache right away. But if Taylor Swift posts,
The system waits. When you open your feed, your app grabs your pre-built list of friend posts, and then it quickly checks the few celebrity accounts you follow to pull in their latest updates and merge them in.
it balances the load perfectly.
It does.
Now, managing all that traffic, deciding what gets pushed, what gets pulled, that requires a very specific kind of traffic controller. The source material mentioned Apache Kafka.
Yes, Kafka is the backbone of this right path.
I hear Kafka mentioned constantly, but usually people just say it's a message queue. Why do you need this separate thing? Why not just write to the database?
That's a great question. The aha moment with Kafka is understanding how hard drives work. Writing to a normal database involves random access, writes jumping all over the disk to find the right row, update indexes, lock tables. It's slow.
And Kafka is different.
Kafka is just a log. Think of a notebook. You just write on the next available line. You append to the end. That's a sequential write.
Which is much, much faster for the hardware.
Orders of magnitude faster. So when millions of posts come in, Kafka just appends them to this log at lightning speed. It acts as a shock absorber. The fan-out service can then read from that log at its own pace. It decouples the chaotic input from the structured processing.
Okay, so we've used Kafka to tame the inputs and the hybrid model to get the post IDs to the right people. But a feed isn't just IDs, it's photos, text, profile pics. Where does all that live?
This is another area where the design is counterintuitive. You might think we'd store the whole post in the newsfeed cache so it's ready to go.
I mean, that would be the fastest way. Just grab the whole object.
But memory RAM is expensive, way more expensive than disk. If you store the entire text, image URLs, and user data for every post in everyone's feed cache, you'd run out of RAM instantly.
You'd be paying millions a month just for caching.
Exactly. So the architecture uses a two-step caching process.
Step one.
Step one is storing only the timeline IDs. The newsfeed cache, which uses Redis, a super fast in-memory store, only holds a tiny lightweight list of post IDs and user IDs. That's it.
So my feed cache is just a skeleton. It's a menu, not the meal.
Perfect analogy. Then comes step two, hydration.
Hydration, like adding water.
It's a perfect visual. When you open the app, the system grabs that skeleton list of IDs from Redis. Then it goes to a separate content cache and user cache to fetch the actual data. The text, the username, the profile picture. It hydrates the feed with the rich content just before sending it to your phone.
I see. That way, if a viral post is in 10,000 different feeds, you only store the heavy content once in the content cache, not 10,000 times.
Precisely. It saves a massive amount of memory. And actually, the design breaks it down into 5 specific cache layers.
Right, I saw that diagram. We have the newsfeed cache for IDs, content cache for post data. What were the others?
There's a social graph cache that remembers who follows whom, then an action cache and a counters cache.
Why does the counters cache need to be separate? That's just the number of likes, right?
Think about the right frequency. The text of a post, it rarely changes, but the like count on a popular post changes thousands of times a second. If you had to update the entire post object every time someone clicked like, the database would lock up. By separating counters into their own high-speed cache, you can increment that number without touching the rest of the data.
It's incredible how granular this gets. When you see a post with a number, but the system sees 3 or 4 different databases working together to paint that picture.
And that's just to show the static page. Now, what about the infinite part? How do we handle real-time updates?
Right, because nobody hits refresh anymore. The old way was polling, right?
Yeah, polling is the "are we there yet?" of software. The client app asks the server every few seconds, is there new content? Is there new content?
Which sounds terrible for my phone's battery.
Terrible for the battery and terrible for the server. In the standard HTTP protocol, the server is passive. It can only speak while spoken to.
So what's the modern fix?
WebSockets.
WebSockets. How is that different?
A WebSocket is a persistent bidirectional tunnel. Instead of a one-off request, the phone says, I want to open a line, and that line just stays open. This lets the server push updates to you the millisecond they happen without you asking.
So if my friend likes my photo, the server just shoots that info down the WebSocket tunnel instantly.
Yes. It's what makes chat features and live updating feeds feel magical.
I want to zoom out a bit to the supporting cast. I mean, with thousands of servers handling caches, WebSockets, databases, it seems like a logistical nightmare. The outline mentioned an Envoy proxy.
Oh, Envoy is critical. In a system this big, servers are constantly dying and being reborn. IP addresses change all the time. If Service A needs to talk to Service B, how does it know where Service B is right now?
It's like trying to mail a letter to someone who moves every 10 minutes.
Exactly. Envoy acts as a service mesh. It sits in front of the services and knows where everyone is, so the request comes to Envoy, and Envoy routes it to the right place. It's the traffic cop.
And how do the engineers know if this whole machine is working? I saw Prometheus listed.
Prometheus is for observability. In the old days, we just checked if a server was up or down. But in a distributed system, up doesn't mean working. A server might be up but responding 5 seconds too slow.
So Prometheus is watching the stopwatch.
It's watching everything: latency, error rates, CPU usage. But it's not just a dashboard, it's the nervous system. If Prometheus sees latency spiking because of the Super Bowl, it can automatically spin up more servers.
That is cool. So it breathes, it expands, and contracts based on demand.
It has to. And for protection, they use circuit breakers.
Like in a house.
The concept is the same. Let's say the light counter service starts failing. If every time the main feed tries to load, it waits for the light counter to respond.
The whole feed will freeze.
Right, so the circuit breaker detects the failure and trips. It tells the main system, stop asking the light counter, it's dead for now. The app then loads the feed without the light counts.
So I see the photo and the text, just not the number of likes for a few minutes.
Exactly. It's called graceful degradation. It is so much better to show a user a slightly broken page than a crash.
Okay, we have the two flows, the hybrid fan-out, caching, real-time. But we're glossing over the 10 million users. All that data, it becomes too big for one database.
And we enter the world of sharding.
Sharding. Splitting the database into pieces. But how do you split it? The outline mentioned 2 strategies, user-based and post-based.
Right. Think of the database like a huge library. In user-based sharding, you assign rooms based on the person who owns the books. So user IDs 1 through 1 million go to room A.
That seems logical. All my stuff is in one box.
It's great for reading your feed. The system knows exactly which shard to query to find your data. It goes to room A and grabs everything. It's fast because of data locality.
Okay, so what's the alternative? Post-based.
In post-based sharding, you file books based on the book ID or the post ID. So your first post might be in room A, your second in room B, your third in room C.
That sounds messy. If I want my timeline, the system has to run to all 10 rooms to find my posts.
Exactly. It's a scatter-gather operation. It's much slower for reading, but it's great for writing because it spreads the incoming writes evenly across all the rooms.
But since people scroll, read way more than they post.
User-based sharding is usually the winner here. You optimize for the read speed.
It's fascinating how every single decision, push versus pull, Kafka versus a database, sharding by user versus post, it's all a trade-off.
That is the definition of system design. It's all trade-offs. There's no perfect answer.
So if we look back, when I pull out my phone and scroll, I'm triggering a DNS lookup, hitting a load balancer, passing through an Envoy proxy, checking a Redis cache for a list of IDs, hydrating those IDs from a sharded database, while the WebSocket keeps a line open for new updates from a Kafka stream.
And it all happens in under 200 milliseconds.
That is humbling. It reframes the whole experience. It's not a list, it's a symphony.
It really is. And remember, we didn't even touch on the ranking algorithms, the AI that decides what order to show you things in.
Oh, right. We just assumed reverse chronological.
If you add the AI discovery engine, the complexity just doubles again.
We'll save that for another deep dive. So what does this all mean for you, the listener? Why should you care about fan-out services?
I think it's about appreciating the invisible machinery of the modern world. We take instant for granted, but instant is the result of these incredible engineering choices, like deciding to treat a celebrity differently than a normal user. Simple experiences are usually the hardest to build.
Absolutely. And as we wrap up, I want to leave everyone with one final thought. We talked about how we store copies of data everywhere, in caches, on the phone, in database replicas.
Right, copies on copies on copies.
So what happens when I edit a post or delete it? How does the system make sure all of those copies get updated at the exact same time?
You are talking about cache invalidation.
The sources called it one of the hardest problems in distributed systems.
It is the nightmare scenario. If the cache says a post exists, but the database says it's deleted, the user sees a glitch. Or worse, ensuring that every copy agrees when something changes. That is a problem that keeps senior engineers up at night.
A problem for another day. But for now, the next time you see that little spinning wheel, just remember, it's probably just pulling in Celebrity's update. Thanks for listening to this deep dive.
Happy scrolling.
See you next time.